Today we bring you Sami Jawhar. Sami works at Kernel, where they're making some very interesting technology for neuroscience. Prior to that, he worked at Zepp, where they also make some cool technology like smart health technology, and he used DVC extensively in his workflow there. Sami has contributed to DVC, and we are so thankful for that, and to have him here today to show some cool things he built and spark a great discussion. So with that, the floor is yours, Sami. Take it away.
All right, cool. So I'm going to try and keep this brief. So I say fewer things and you guys say more things. I'm just going to present a few ideas that I want to bounce off all of you about how to do experiments without, how to do lots of experiments and without necessarily cluttering up like your Git or GitHub or Bitbucket or whatever with pull requests. And how do you manage your experiments and whatnot? So, okay, I'm going to share my screen. And okay, so here's some stuff I built. So, yeah, so the two things I'm going to talk about are running an experiment remotely and then integrating DVC with other tools so in that order with breaks so we can discuss. So why do I want to run an experiment remotely? Because this gets back to what I was asking at the end of the last office hours, which is, what is an experiment? Like, at what level of granularity do you experiment? And at what point do you share that with your team? Or at what point are you just doing it for yourself? And if you're like me, you really like tests. And so you like to run lots and lots of experiments. And there's some cool tooling with CML and whatnot to open a pull request and then have it report back the results. But if you want to run a lot of experiments, you don't want 100 pull requests and whatnot. So how do you manage that? This is something I helped, a pipeline I helped set up when I was at Huami, which is now called Zepp, which makes cool health wearables. And I was on the AI team there doing machine learning. And after surveying the landscape of tools out there, I decided to start using DVC because it was really lightweight and it didn't try to do too many things. And we can talk about that as well in the next part about integrating stuff. So I got to the point pretty quickly where I wanted to run experiments, and this I might have even been before CML, or when CML was like pre-beta or something. So a lot of what I say might have changed since 6 months ago, and that's also something that we can have fun discussing. And you can tell me, oh, by the way, all this stuff you built uses now because there's this other thing, and I'd be very happy to learn that. So running an experiment without a PR, it's pretty simple. We use Bitbucket, but you can use any Git host. The idea was, you create your commit or an experiment commit. You push it to your host with a special commit message, and we had all these keywords. So like here I have them Acme run. So you put in your commit message, Acme run, and your Cloud Runner will. The webhook will fire off to Lambda. Lambda picks up that commit message. It submits a job to the AWS batch. AWS batch runs your job. There are like two little bash scripts, a job setup and a job run. So job setup does things like cloning the repo and setting up the DVC cache. You can have a persistent volume or EFS block storage to keep your DVC cache for all your experiments, which can help speed things up. That happens in job setup, and then it calls job run. And job run just literally just runs DVC repro or DVC experiment run with whatever experiment parameters you would provide. So they're just really, so it's like two bash scripts and a webhook and a Lambda function, right? So an AWS batch job definition, I guess. So really simple. And now you can, you don't want to necessarily open a pull request, but you can make a commit. You can tell Bitbucket, you can tell the Cloud Runner to run it for you, and then it'll post back the results with your DVC diff, right? Your metrics and your plots and whatnot. So that was the first step. And so that would let me run an experiment without opening a PR. And again, why would I want to do that? Well, because I want to run lots of experiments. Like I want to run 400 experiments and figure out which is the right, model, which are the right parameters, all that kind of stuff. And I don't want to do them all locally because maybe my machine's not big enough, or maybe I don't want to wait for it to run through 400 experiments, sequentially. I want to run these all in parallel in the cloud and get my results and see what's going on. And so there were two different workflows that I had for doing that. The first is to just directly call AWS batch. That's the one on the left. You just directly call AWS batch, submit job. You give your experiment parameter that you want to provide. So this is like if you're doing a parameter sweep, you could imagine iterating over a bunch of different experiment parameters, and just you submit those, and those get passed to the job run when it calls DVC experiment run, and now it creates a bunch of experiments and pushes them to Bitbucket, right? And the other way would be to instead queue up a bunch of experiments. This is the one on the right. Queue up a bunch of experiments and then read them off. And then this was before DVC 2.0. So now we have very nice DVC experiment branch and DVC experiment push and stuff. This is much easier. Before I had a little bash script that would like hop into the temporary experiments directory and pull stuff out of the git stash and then make branches out of them and push them to Bitbucket with the commit message. And then again, that triggers the Lambda function, which triggers the batch, which then submits the results. And so what you end up at the end is the same. Is you end up with a bunch of experiments branches and in Bitbucket, and each of those has, what are the parameters this was run with, and then the DVC diff report. So, metrics that change, the parameters that change, any plots if you have, stuff like that. So those are two things. One thing, I guess, and then how I used it to run experiments, because I like to run lots of experiments. So this is the first point I'm going to stop and say, like, what do you guys think? What is an experiment to you? Do you run lots of experiments? Am I the only one? Am I crazy for running? Because it's not uncommon for you to run I want 500 experiments and then tell me what the results are. When do you run an experiment for yourself? When do you, open a PR with an experiment? Do you use PR for experiments, or is that like, oh no, what if this is bad? Yeah, how do you guys manage this?
So I have an interesting perspective in that I had thought I tend not to actually run like a bunch of different experiments in terms of just selecting the model, but rather I'm working with one model, but I'm trying to figure out how to improve that one model. So I'm like, okay, what if I calculate the metrics differently? What if I, pre-process the data like this, right? And then therefore I find myself actually I do one experiment at a time, or maybe two, because I'm not just instead of like trying multiple model architectures on the same data, I'm usually trying the same model with variations of the data or the metric, variations of the data or the metric, the evaluation functions. And so I find that I don't actually run like the amount of volume that you've shown, but perhaps that might be because I'm working more like NLP in that space.
Yeah, I was also reading about some examples that you might need to have many experience, and all of those experience actually generated data that you want to keep them to compare.
Well, I mean, one example, that I was running. So I was, implementing. I was considering using knowledge distillation for one of our models because Huami, or Zep, I guess. Now they're called Zep. Zep, they make these health wearables, so the models have to fit on very small, in very small runtime space. And so you might train a big model, but then maybe it's worth using knowledge distillation to distill that down into to a much smaller model, or into several smaller models. And one thing, if you read the original knowledge distillation paper, there's this parameter in calculating the objective function where you're supposed to divide by, I forget what it is exactly, but it has something to do, divide by the square root of the size of the gradient or something like that, because you have to account for, I honestly don't remember, but there's this parameter, there's this two options of implementing the objective function. And actually, it's not really an option. The paper says like you have to do this if you're comparing multiple models at different temperatures, which is what knowledge distillation uses for like it's a hyperparameter. You have to divide. That's what it is. You have to divide by the square root of the temperature because the gradients scale with the temperature. But if you look at any implementation of knowledge distillation that's out there, no one does this. It's like they skip that paragraph of the paper. And so I thought I was going crazy. I was like, am I just insane, or or have I just completely misunderstood this? So one thing I did was I did a parameter sweep over possible temperatures and other, small hyperparameters, but then also with or without that scaling of the gradient. And I wanted to see what the loss landscape looks like over these, this range of hyperparameters. And if there was some reason to actually scale by the temperature, and there is actually, if you look at the loss landscape, it's much smoother. So like that scaling by the gradient actually does normalize, like regularize the objective function and makes it so that it's actually, traversing a smoother landscape. And I wouldn't have been able to do that, changing one experiment at a time. Like I needed to see the landscape. I needed to see the entire loss landscape and see how it varied. But even if you're doing a simple architecture sweep, let's say you have 4 parameters and you have 5 different variations of each of the parameters. That's already a lot of experiments. And, so doing any kind of, not like any kind of random search of your parameter space is going to easily, lead to lots of experiments. So I feel like, how is everyone not doing this? What am I missing?
I can explain my experience with this experiments. I think amount of experiments you run depends a lot on the phase your project in, based on my experience. When you're in experimentation mode, then yes, you need to run like a bunch of experiments, like sometimes dozens, sometimes in hundreds or in thousands. However, when your model goes to like closer and closer to like mature stage, to production stage, you don't need to iterate too much. Like one example might be, we have a model which runs like in production, in batch, and so no matter what, but it kind of affects the business. No one wants to touch this model, right? You need like a good reason to do this. For example, dataset was updated. Let's retrain the model, make sure it's good, and then deploy it. We are talking about like one single run. Sometimes there are like a few runs. Let's try to optimize it a bit. We got like a few ideas. Again, it's about like just a few runs, maybe 3, 5, but not like 17. It's just a different stages, right? So like experimenting stage and then production stage. On another extreme, there is like prototyping stage when you are working on a baseline. In this stage, you probably don't need even experiments. You just like create like a Jupyter notebooks and do whatever like crazy stuff like you would like until it starts working. And then you jump to experimentation stage. So prototyping, experimenting, and then production. And like very few experiments here, dozens, hundreds there, and crazy amount on the prototyping stage. That's how I usually see this picture.
Cool.
I personally think it's a pretty interesting discussion. I appreciate you asking the question. Because I think, at least for me, in my experience, there's a lot of ambiguity around what an experiment is, and I've had intense debates, with colleagues at work on, what we consider an experiment personally. But, I think maybe the way I differentiate it, I think of an experiment as something that maybe I could even, write a small report about, and it kind of aligns more with this kind of, you might want to do a PR type concept where you're kind of documenting your findings, what your hypothesis was, why you think you might have been able to improve the model, whether or not it turned out like you expected. Whereas I kind of think about maybe the smaller runs just as it's one version of an experiment or one run within an experiment. That might include things like hyperparameter tuning and things like that, which I wouldn't, certainly can learn things from those runs, but I personally don't think of those as experiments.
Yeah, I think actually you're getting to something. I think what you just said is really good. Those are like individual runs within an experiment, and then an experiment is something that you intend to like provide a report on and say, here is the results, right? I had this idea, I had this hypothesis, here are the results. And I think that's important because what you need, to get to those results are lots of, in my opinion, you need lots of data, right? You need lots of different attempts. You need lots of different runs, as you put it. And so in my mind, that translates to, if we're going to translate that to like DVC terminology, like what are the actual commands that you can run to do this? It's going to be DVC experiment run, right? So whether or not we call the DVC experiment run an experiment or a run within an experiment, you need to do a lot of them the way I'm seeing it, so that you can put together, some results and share them. And maybe I can share a different screen now. And someone actually asked in the Slack if I could provide an example. So I'm going to provide an example because I did exactly what you said. This is what we do. You assemble all these experiments and you put together a report, and then that's your PR, right? Your PR is like, here are my findings, and here's the hyperparameters I'm going to go with. So see this, okay. So here's an example of, a PR that I would open. I'd say, okay, here we're going. Let's try some multi-level learning. Let's, combine K-clustering with other stuff. And then I put together this PR, and then here's the results. And then here you can actually see examples of the diff reports that Cloud Runner could report back. You'll see these model report run by the machine agent, right? But anyway, I put together this report that, for example, compares the parameter sweeps. So here I'm looking at whether or not we include certain features and whether or not we use knowledge distillation, how the different runs compare to the mean over that run, over that group of experiments, or the baseline, and and then here's etc. So there's an example of one. So I'm doing this architecture search. I'm like, I want to try different CNNs, LSTM layers, how many units, etc. Then I put together this PR that says, all right, here's what I found. Here's what including each of these elements of the architecture. Here's how they each individually change the model performance. Doing kind of like an ablation test, and and then some of my findings. And here's what I recommend, and my other notes. Then again, here you can see the machine reporting back its diffs and whatnot. So in my mind, that's kind of going along with what you're saying. Like an experiment is a combination of all those runs, but you need lots of runs, right? And unless you're going to wait for them all to run in sequence on your laptop, you need to run them somewhere else in parallel. So that's one thing I think that an element of tooling that I feel like can be. I'd be interested to see how it develops. Let's say.
Yeah, so it sounds a bit like you're talking about experiment run queue with the jobs option, except, yeah, it's a remote executor that kind of automatically will run in parallel on multiple machines. Yeah, so I think we're having discussions about maybe supporting these kind of features in future with DVC to make that really easy. So you kind of have two problems. One is the hyperparameter grid search, and secondly is provisioning multiple machines and distributing your experiments amongst all of them. So DVC solves the first kind of problem, I would say, for now. You can queue experiments, as you said with DVC2. But yeah, we haven't yet solved the problem with making it super easy for you to distribute them on multiple machines.
Let me pitch one idea, and then we can move on to the next half of this, unless there's lots of more interesting discussion. So you can do the DVC queue. You can queue all your experiments, and then I think something that could be really simple as just a proof of prototype, like is this useful for people, is a run option where instead of running the experiment, you just give it a command to run, and it passes each of those parameters into that. So for example, I can say DVC experiment run, on my queued, but instead of running DVC repro or whatever, call this bash script, and that bash script will accept the experiments, and it'll handle the logic of queuing things and provisioning. Like DVC doesn't need to suddenly become the expert of how all possible cloud providers you provision instances. Just let me queue my experiments and then play them back to me, and I'll do with it what I want. Like you're just kind of, the DVC is kind of playing the bookkeeping role, and then I can pass that to anything. I can pass it to Terraform, I can pass it to whatever, and it can manage queuing them. So there's a one idea of one really easy way, where it's just instead of running DVC repro, just run what command I tell you, and that command will be a bash script that handles things behind the scenes. What do you think about that?
Yeah, Sami, I think we've talked about it a little before, but I think you have some really interesting ideas, and I think it hits on a lot of different things that we're trying to work on and improve for DVC, like both in terms of being able to run things remotely in a lightweight way. So that's kind of one piece of this, right, is lightweight remote execution. Like you can do this to some extent in CML, but to your point, you don't always want to PR for every time that you run something, right? And then the other thing I think that you're getting at is kind of, yeah, what is, now that we have some of this experiment tracking functionality, how do we best leverage that without necessarily having people be tied to or running something in a DVC repro or whatever, you really just maybe want it to keep track of what's being run and not actually manage the execution so much, right? So yeah, I think that's really interesting. And also conceptually from, your experiment point, I think you have a really, I think you have a good point. I mean, I think I know I've definitely been guilty in the past of just running grid searches and things without any sort of, without, thinking about it at all. Yeah, right. You just kind of, okay, which one's best? I'll go with that. When really, like, I think, Sami, you've mentioned, I think you're working now in a place where a lot of people are more doing traditional science, where they're doing hypothesis testing, and like really you should have a hypothesis, you should have a robust experiment design, you should be looking at whether the differences between these models are significant and things like that, right? And I think we often tend to overlook that when we're trying to do our hyperparameter tuning and things like that.
It's still, yeah, I would still say, so you've replaced pull requests with commits. I would say you don't even need the commits. You could use the experiment framework, which has sort of ephemeral commits. So you can still experiment, push, and pull. So once all of your different cloud runners are finished, you can pull all of their results and then do an exp show locally to get your table of reports. I guess that's what you've been doing. I don't think there's a convenient way to automate the pull request with all of those reports. I think that definitely requires human intervention to say, oh, these tables are important, those aren't. Yeah, sure.
No, absolutely, agreed. And yeah, this is gonna be the next thing I'm gonna talk about, is because a few of the things that you and Dave and a couple of the people have mentioned are more or less kind of what I did in this next step. So, okay, here we go back to sharing screens. So next step, integrating with experiment trackers. So I mentioned that, so the idea I just pitched, like, what if DVC, queued all your experiments, and then you just told it, instead of, run DVC repro, just run the command I tell you. Well, you can also approach it from the other direction. What if you get all your experiments somewhere else, and then you submit them, to DVC, and it runs DVC repro, and then you want to, you want to report all those results somewhere, right? That last thing that we were just talking about. So the first thing I did is exactly what you said, is I pull all the experiments down. And again, this was before we had DVC experiment pull and push. Like, this was, again, going and grabbing things and then sticking them into DVC. And I forget who it was. It might have been Pablo, who's like, this is gonna break like next week, man. I was like, just don't worry about it. I'll just do it. Don't worry. But anyway. So I did that, and then I display it in a notebook, because I do DVC experiment show, get the JSON, dump it in a notebook, and then, make those plots that I showed you. Well, you could also, another thing that I eventually landed on is you could add this track experiment stage, where what track experiment does is it essentially uses whatever experiment tracker you want to use. It consumes all the outputs that you've already defined in your DVC pipeline. And it's just this really simple Python script here, like you can see on the top right, track experiment, that just consumes all those files and then reports them to whatever experiment tracker you use. So like in this case, I'm using weights and biases. It just consumes them, consumes your parameters.yaml, says, here's my config, and then reports them to weights and biases. And there's a couple important things to note here. The first is, this is a frozen stage in my pipeline, because I don't want to run it every time necessarily. And another thing that I like about this, and the reason I chose DVC over other data science frameworks, is because they all want you to like instrument your code with their stuff. Like, just even to run a basic script, they're like, oh no, you have to import our Python package and run everything with that. And it's like, bro, get out of my face. Like, I just want to, ML train, and you're sitting here telling me I have to 1DB init every time. Like, just, go away. So instead, you can move all of that logic into just this last stage, which all it does is just report the results to your experiment tracker, which is all you want it to do. You just want it to track your experiments. You don't want it to snapshot your entire code base. You don't want it to do all these crazy things that all these experiment trackers seem to want you to do. You just want it to track your experiments. And then in that cloud job runner, when it runs experiments, that's this bottom right. Just add this little snippet to your job run at the end, where if it's an experiment, it unfreezes that track experiment stage and then runs the track experiment stage, right? So now in your job runner, if you're running experiments, it'll unfreeze that track experiment stage and push the results to whatever experiment tracker So again, here I was using weights and biases. And so in this way, you can get all the nice features of DVC and all the, the pipelines without having to instrument your code and the data versioning and the reproducibility. And you still get the integration with whatever experiment tracker you want without their nasty trying to get their API all up in your, in your Python. Which a lot of this might now be different with DVC Live, and I haven't yet played around with that, so I'd be interested to hear what the community thinks about that and what learnings we have there. And so, just this little addition here, and then what you could do now, putting this all together, what you could do with things like weights and biases is you could start a parameter sweep in weights and biases. And the way that works with weights and biases is you can either launch a controller, on some machine or just use the cloud one. And then what it wants you to do is to run an agent. And so then the agent will connect to the controller and it will, get experiments one by one. And then it will run whatever script you tell it to. Again, so this is like the parallel between what I was saying. What if DVC experiment run? You could just tell it, run this script for me with these experiment parameters. And that's what I did by using weights and biases. So the agent, what I would do is let's say I want to run 4 machines in parallel. I'd run an AWS batch job, and the command for the job would be, instead of job run, it would be launch the WAN-DB agent, and the command for the agent would just be job run, right? So the agent would pick up all the, it'd get the experiment parameters one by one from the controller in the parameter suite, and then it would just call my job run script, which is essentially what I was saying maybe DVC could do. And then the job run script just does the same thing that we've been talking about this whole time. And so in that way, and then again, using that track experiment stage, it reports the results to weights and biases. So that way you get, so now what we have is somewhere where you're deciding what your parameter sweep logic should be, just whatever that is. In this case, it's weights and biases, but it could be, anything. And then you're using something to iterate over those parameters and call a script, which in this case is the weights and biases agent, but like I just said, could be DVC experiment run, except run whatever I tell you to run. And then those run your job, run your experiment, and then use this track experiment stage to report the results wherever you want it to, because all that's contained in one stage. And then you can, get all your nice plots and visualizations and all that other stuff. So this was kind of the culmination of the pipeline that we were working on, where we put it all together, and now we get experiment tracking, visualizations, persistent sharing of reports and all that other stuff, and lots of parallel jobs. And this is the end of what I have to present. And now back to you guys.
Great, thanks, Sami. Anyone want to add questions?
Yeah, I have a question. So could you please clarify the part when you are reporting your metrics through weight and biases? Are you saying that you extracted a separate step in DVC, like probably the last one, when you do the actual reporting, right? Okay, that's very interesting, because usually we have seen many people who use DVC with this kind of reporting tools, and usually it still happens in one single stage. But you are saying like, let's decouple the actual code, right, from the reporting part, because reporting part is like the tool specific, right? Weight and bias specific, MLflow specific, and yeah, that's really good. I think design pattern.
Yeah, exactly, because you can then take that track experiment stage, and if you want to ditch weights and biases and switch to MLflow or your own, personal server or whatever, you just replace that one Python script, right? It's just and everything else. And what's great about it is everything else is still in your Git repo, still in DVC. So you still have your entire metrics history and everything. All you're doing is just changing where you're reporting with one script. So
yeah. So in this way, basically, you're using all the benefits from kind of both approaches.
Which I think it's important to point out is like why I chose DVC to start with, because it doesn't try to do too many things, right? It's like, this is what I do well, and I'm just going to do that. It's thank you for doing that. Thank you for not trying to do way too many things. And so So I think that's an important philosophy to keep going forward.
Yeah, that's really cool, and I think we should, as a DVC team, we should think a bit more about this, like what we should do about this best practice.
Mhm.
Really cool, really cool.
Yeah, I think Sami, you mentioned like DVC Live, and I think that and checkpoints are some things that have been introduced where it is a little bit more integrated potentially into your code, because there's potential need to sort of track to log as you go through multiple epochs of training, for example. So what is that a need that you have? Or I would be curious what people think about that kind of workflow where you maybe want to be tracking your metrics for each epoch or every few epochs of training, and how you like to record things in that kind of workflow.
I have some thoughts on that, but I'm going to wait for other people to say words.
So I've some opinions about this. So I work at Papercup, and we train text-to-speech systems, and they're very, very slow to train. And so waiting for something to train in any, without seeing, it's basically we have to lock everything as it goes, because we basically just need to let it go, and sometimes it will go for weeks. And we need to be able to track as we go. And so it is a slight problem having to have a thing where there is a neat end. So sometimes we actually even make multiple stages where kind of a stage is a few epochs, or something like that. But yeah, that's just this one particular feature.
And so I personally haven't run into a need for using the checkpoints feature, because one, because I'm not running, a lot of the time I'm not running the experiments locally, right? I have this whole thing about how I'm running things remotely and running 400 of them at a time. So I'm not babysitting a job, but I can still get the benefit of looking at the history by, just logging the history and then reporting it, right? So for me, the live thing wasn't as useful, and it probably has to also do with the types of models that we're training in, and the size of data that we have and stuff like that. But as long as you capture that history, so if you're doing things like running lots of experiments in parallel, you're not babysitting them, right? You're not watching them as they go. So that feature doesn't really matter there. But if you are running them locally and watching them, I don't know, maybe maybe it's more useful in that case, but maybe also there are already tools to do that, like TensorBoard Live and stuff like that, where you can monitor, if you are monitoring, where you can monitor. And but it's honestly just not a feature I've played a lot with. So
but I think it might depend on how much resources it take, because if you need for each single experiment you need a super heavy expensive machine, right, and train for days, as Chris mentioned, you might consider watching them more closely. I guess.
I personally, I'm sure that there are lots of use cases out there where that live feature would be a great utility, but I think I would mimic some of the comments that Sami made, just in the sense that it can be kind of overwhelming, right? When you're looking at all these MLOps tools and you think you find one, and you realize, though, in order to be able to use it, you're having to instrument your code in so many different places. And I think, I don't know, the idea that Sami proposed here with having a way to kind of have that be more modular at the end of the pipeline for the use cases that can accommodate that, at least, I think that's a pretty interesting concept.
I would echo the sentiment that one of the things that attracted me to DVC in the first place was that it didn't touch my code, and I could just run whatever command, and that was, and it, yeah. So I would say that.
Well,
yeah. So
Go ahead,
yes,
Nick.
Ring, please.
well, it's just not about exactly the topic of discussion, but the last phrase. I wanted to second this, that it's really, really a big plus that it doesn't touch your code. And it's even bigger plus if this code is not yours and it's someone else's framework, and those people, they just like don't really care which tool chain, which tools do you use to track your experiments, to organize your workflow. So since DVC doesn't touch neither your neither theirs code, doesn't require you to integrate with your code. It's just easily to integrate with third-party frameworks and libraries. Well, I just seconded opinion of the previous person.
Thanks, Nick.
So I wonder, just to pitch an implementation idea, if the idea of the checkpoints, right? If you would be able to specify, a watch, the outs, you have your outs, and then you specify an out, and you specify watch true, and you use something like iNotify to just watch for changes in that file and then snapshot each one, and that way you don't have to dvc.checkpoint, in your code. Could be another way of implementing the checkpoint feature while retaining the whole "don't touch my code" thing, which seems to be resonating with.
Yeah, that's a good idea. I can explain actually why we haven't done this with checkpoints in DVC. If you do this, if you dump checkpoints based on kind of state of the files, you can easily synchronize the state. Why you need experimentation? You kind of need a connection between user code and DVC code, which says, okay, I'm done with checkpoints. Please do your job of saving checkpoints, and once it's done, notify me, and then I can continue. So you have like a clear protocol, and you won't break the state. Otherwise, if you just like set up like file watchers and then report the state after file change, you will be breaking the state all the time, which might be not a big problem, by the way. If you like running like 100 checkpoints, okay, like a couple will be like broken, it might be fine, but in general, it might be dangerous.
Well, you could, one way of doing that then is, instead of watching, all the files individually, you specify one file that is your state file, and just, for example, each time you just dump the epoch number to that file, right?
Okay.
Whenever that file changed, it snapshots whichever things you've. And not to get like into a technical discussion of how to implement checkpoints.
This is exactly how DVC works for checkpoints. It waits for like some specific file to change, and you can do like checkpoints without library, without importing like DVC checkpoints and running the code. You can just create the file and then destroy the file. This is like how communication works under the hood.
Cool. All right. Yeah. Like I said, I haven't played around with it, so my own ignorance here is that
it's not documented. It's not yours. It's not documented well, I would say. It's documented somewhere, but like it might be not easy to kind of fully understand this protocol.
Yeah, I think I've looked at it a bit, not enough, but I have to say it wasn't. I was a bit like, I'm not entirely sure how I would use this. So I think.
Does anyone have any other thoughts or questions or?
I have a question. As I really enjoyed the presentation, especially as it sounds like something I will need for my future use case. So for me, short introduction, I'm pretty new to all of this, and I'm like the person who has to look in MLOps and no one else knows what's happening. So I'm trying to get my hands on, and I've spent the last months comparing different frameworks like MLflow, Metaflow, and DVC. And so for background, I work at a German scientific institution. So we also have to handle large data sets, a lot of data. We have to be very careful about reproducing stuff, and especially, and that's where I got very interested in the solution you presented, Sami. If it's okay to call the first name, I just don't know how it's here. Is because we have custom backends. So we have especially much to do with high performance computing. We have our own data centers. We have Slurm to handle with. We have batches, we have modules and all of that stuff. And so this is something I haven't tried out yet. So currently I've finished the theoretical phase with like toy examples and stuff. And now I'm actually starting to explore real life examples. And I have to see how to make this work with our high performance computing environment. And these are also, of course, I haven't found much about these use cases yet on the internet. And so what you mentioned sounded like something I could make work probably. I mean, you have this job setup script and this job run script, and maybe I could like, you know, do the same thing on the cluster and yeah, manage this learn job and somehow extract the experiment. So it's not yet clear to me, but it sounded like something that could really help me with the task I had. So if the material is somewhere, I'd be very thankful because I have to look into that.
Yeah, I can make a public GitHub for this with just the caveat that, again, this was made before some of the nice improvements that have been added to DVC recently. And so some parts, it might be useful for the DVC maintainers to be like, yeah, you don't need this anymore because you can just do this. But yeah, I can, you know, it's all just, like I said, 2 bash scripts, a Lambda function, and some stuff. And actually, Netta, I'd be really interested in talking to you more about your particular use case, because it sounds very similar to now what I'm dealing with at Kernel, which again is, you know, scientific data sets and on-prem high performance computing infrastructure.
Yes,
and I think I'm approaching something that might work in both of our cases. So I feel like we had some something to talk about.
Like, just be sure, I'm like pretty new to that. I'm like exploring it single-handedly right now. Because like I'm still in our machine learning team, but like a couple of months ago, I told my boss like, hey, we probably need to, well, we need to see that things get actually reproducible when we start with machine learning, and now others started having interest. So it's really still very in the beginning, and I also just work myself more into this MLOps role. So probably a lot to learn from me, but as soon as I start trying out the real life experiments, I mean, I did this one blog post, which was like an introduction, and I plan to share whatever I encounter more. So would definitely love to talk as soon as like I have something useful, and definitely glad to listen. So thankful for any help, really. Also how to approach the whole topic because it's very new.
This is so awesome. I'm so happy to see people connecting here, and now you can be friends and help each other, and I can see everybody on the thing today. And this has been really an awesome talk. We have a few more minutes, so if anybody has more to share, go ahead.
May I ask one more question to Sami? Probably he has an answer. Well, basically we have like 2 choices, like run several jobs with like different parameters in parallel, or run them in the sequence, right? The question I have, if I do run all of them in parallel, and like I have 10 jobs in parallel, and then I just select the best, choose the best, and drop everything else. But is there a way to actually like, well, I don't need any weights or any other outputs I've got from parallel run. But what I do probably want to have in a PR report, just to join all the results of the run in some kind of a table or something, to show that the one job I actually choose, the one set of parameters I've actually choose, is really the best one. Is there any way to do something like this?
So yeah, there is. I think some of the DVC maintainers are posting links in the chat that you might find useful. But so a couple ways I did it was, and it's a lot easier now, I think, with DV experiments. You can pull the experiments after they've been run, and then DV experiments show, you know, it'll show you the results, and you could do show JSON, and so you can get a JSON output and then prepare any kind of report that you would want, like ingest that into your Jupyter notebook and make different graphs like I did. Or you could, you know, report them all to your experiment tracker with, you know, some experiment ID, and then they're all grouped there as well. But DVC people, what other things am I missing, that nice candy that's been added that I don't know about?
No, I think you did a good job.
The show JSON is pretty much it. Yeah, go ahead. There's also the default markdown tables, but yeah.
I mean, I think you guys are hitting on all the conversations that we're also having about how do we make this easier for you to ingest all those results, and In addition to the other things that Sami already talked about, these are exactly the questions that we're trying to answer. So we don't have, we're talking about ways to do that, providing APIs, things like that, but we don't have any, news for you just yet.
Yeah, Dave started this discussion like maybe 3-4 weeks ago, and yesterday we had a really great discussion, really great meeting about how we can provide data for kind of analytics on top of experiments. So it's exactly about this, how to join all the experiments data, how to slice and dice, extract maybe some insight.
So just also a feedback for why my choice also fell to favor DVC is not only also mentioned it's not code intrusive, which is super important, but it's also user based. So when I look at this, I'm not thinking only of people like me which have a computer science background. So I will find my way around the command line, but a lot of our users are data scientists or scientists with some Python knowledge, and you can't expect them to, do all this huge whatever framework and coding stuff because they have other work to do. And so when all of these features are really good, and especially usability and entry points, and maybe at some point a distinction between DVC admins or people who have to do the more complicated stuff and simple usage for not as technical people might be helpful. But this is definitely one of the very important parts, the user base. Often data scientists are not programmers, and this is important when you have to interact with a framework. We're happy if our scientists have heard from Git. So Git is maybe the bar, and especially because it's so integrated with Git was also an important choice, because when I looked at MLflow, it's amazing, but it's vast. You actually need a person to maintain this. Despite I really like the idea of the different components, but that's another story. And so yeah, just wanted to let this feedback here. So for us, this direction is pretty good. Because
Thank you.
Yeah, 100%. And I'm preaching to the choir. All of you obviously are advocates, but I think with so many of these MLOps tools that I've evaluated for our company, I feel like they're throwing out the baby with the bathwater, right? We've done software development. The same processes don't work perfectly for machine learning, but there's so much still that can be leveraged. And I like that DVC has taken the things that work and is only trying to tweak the things that don't work to make it accommodate data science. Because some of these platforms, I won't say names, it's just they just try to rebuild from the ground up, and it's just throwing out all this good that's been done over the last several decades in software development.
Yeah, I really want to touch on that. I'm glad you said that, because that's what really bugs me. Is it's like the makers of, and I will say their names, the makers of MLflow and Metaflow took a look at the landscape and they said, a lot of these data scientists don't know how to use Git. Okay, so let's make something that replaces Git. It's no, that's not the right answer. Git is really good. Teach the data scientists how to use Git. That is the answer. Oh, let's snapshot the entire code base in every experiment you run. No, Git does that perfectly fine. It should, I feel like a good tool enforces a good workflow. And that helps train people who are new to the field, right? It's not oh, these people don't know how to use Git, so let's just pretend software engineering hasn't figured this shit out. It's what are you doing?
By the way, one more question. Oh, sorry.
Neda, were you going to say something?
No, I just wanted to say, yeah, I completely align with that opinion. I just wanted to add that I said I spent some time really going through the documentations of MLflow and Metaflow, and I just realized they have really different approaches, and I think it's a really different scale they try to address also. So I feel like that especially Metaflow has some really elegant ways to, especially this data flow paradigm, and especially the focus on namespacing and text in order to enable collaboration. This is really a setup which is meant for huge, large setups with a specific team structure where people or where organizations have actually the money to pay and to throw onto this process. So, and MLflow is super vast, and it has also some interesting aspects, especially this different components. So you can either use only the tracking component with the UI, which maybe could be done by someone with not as much program background, but you also have this vast plugin functionality to include different backends, which is useful if you again have people to pay for having this initial coding stuff. So I think what is important is for me, it was important to see or to find out that they're similar, but not the same. They address really different use cases. And again, of course, with Sami, like for the use, our institute runs when scientists, and especially when data scientists directly have to use this, DVC is definitely like the way to go, because it really focuses on providing, and is built around, as said, good principles, and you don't have to have all this computer science background and deal with the infrastructure and whatsoever, of course. But I think I'm actually currently writing a report for myself. Maybe I can share this at some point, and gladly to be corrected or getting the opinions. This was just like my first impression when I tried to compare the tools. There's actually a question that I have, but I still haven't found it out yet, maybe for another discussion. How is your experience with collaboration and using DVC? Just a very naive question, but I haven't tried it out yet, of course, but this is super important. And Metaflow seemed nice to it, MLflow not so nice. So, and DVC probably around usual Git collaboration, because it's very integrated into the tool and you actually don't have to care that much about it.
Yeah.
I would say it's one of the reasons why we're using DVC is for collaboration. The fact that you have everything is in the repo. And if you want to know how an experiment runs, you just go to the repo. Just like if you want to know how the code runs, you read the code, you just read the YAML file, and everything is there. And there's nothing else that you need to do. But yeah, one of the reasons why we're using it is because it makes it easier to go between different team members and between the same team member, but 6 months later, and everything like that.
Oh, I love this. I'd like to point out, so the users had really positive feedback about do one thing well, don't reinvent the wheel, and we're using you for collaboration. I love this. None of us said anything. Yay.
Yeah,
Perfect.
I like the idea of just not, collaboration is something that's been done in software development, again, for a long time, right? So we use GitHub, and if we have experiments and we want to comment and have a discussion on it, or if we have an improvement that we want to suggest, there's already a platform for that, right? We don't need the MLOps provider or tool provider to create a brand new ecosystem that needs licenses and access and senior sign-offs to get people into that platform, right? We have Git. It works.
Cool. Well, we are at time, so I'm going to close now, but I want to say thank you all for being here today. This has been the most awesome meetup. Thank you, Sami, for being here and spurring on this discussion and showing everything that you've built. In the future, for all of you, when you're building stuff, please reach out to me in Discord or my email. I put it in the chat, and we would love to have you share what you're building with DVC as well. At our next office hours in July, we will be hearing from João Santiago, who created DVC RU. So if you know any R users on your teams or friends in the MLOps community that are R users, there is a way to use DVC with R, and he will show about that. And we will also be showing off Studio. And if any of you have started playing around with Studio and want to share about your experience with that, please let me know. We'll be having a demo for Studio then as well. And last but not least, we are going to be introducing some DVC Learn meetups, and that'll start on July 14th. And so these will be more like for people that are just getting started with DVC. So if you want to share with other people that are just starting to learn and kick the tires and figure things out, these are designed to help you along in that process. And they'll be like in opposite weeks of these meetups, the office hours meetup. So anyway, that's all we have. And thank you again so much for being here. This was primo discussion. Way to go. Yay. Happy MLOpsing. Have a great week.
Thanks.